everyone, welcome to V Chemistry Hub. After a long gap, I am coming back with a series of videos. In this video, I am discussing about the branches of chemistry. So, chemistry is having so many branches. The main branches of chemistry are six: organic chemistry, analytical chemistry, biochemistry, nuclear chemistry, industrial chemistry, and inorganic chemistry. As I said, chemistry is having so many branches. The main branches are these six branches. Analytical chemistry. Analytical chemistry is the study involved how we analyze the chemical present in the sample. For example, consider a coffee and take a sample from that coffee. So, in that sample, how much caffeine is present in that we can analyze, and the percentage of hydrogen peroxide in that sample and ethylene glycol and cyanide, we can analyze the percentage of the chemical in that sample by using analytical chemistry. Now coming to the areas of analytical chemistry, which includes forensic science, environmental science and drug testing and so on. The classification of analytical chemistry is of two types: qualitative analysis and quantitative analysis. Coming to the qualitative analysis, which employs methods and measurements to help determine the components of a substance, and whereas quantitative analysis helps us to identify how much of each component is present in a substance. So, both of these qualitative and quantitative analysis can be used to provide important information about an unidentified sample and help to identify what sample is. So, this is all about analytical chemistry. Now coming to biochemistry. Biochemistry is simply biology and chemistry together we call as biochemistry. So, biochemistry describes the origin, formation, function, deficiency and symptoms such as enzymes, carbohydrates, proteins, DNA, RNA and so on. So, biochemistry concerned with the chemical and physiochemical process and substances that occur within the living organisms. So, simply biochemistry is the study of chemical processes in living organisms is called biochemistry. Everything in the body is made up of atoms and molecules of different chemical components like carbon, hydrogen and oxygen. Biochemistry is classified into enzymology, which is the study of enzymes, endocrinology, which is study of hormones, clinical biochemistry, which is study of diseases, and molecular biochemistry, which is study of biomolecules and their functions. So, this is all about biochemistry. Now coming to organic chemistry. Organic chemistry is a branch of chemistry that studies the structure, properties and reactions of organic compounds which contain carbon in covalent bonding. Organic chemistry is the study of carbon compounds such as fuels, plastic, food, additives and drugs. Organic chemistry deals with the study of carbon and the chemicals in the living organisms. Common example is a photosynthesis in a leaf. It is the process comes under organic chemistry, and the branch of organic chemistry involve many different disciplines such as a study of ketones, aldehydes, hydrocarbons and alcohols. Organic chemistry is in diverse area. Some of them are medicinal area, environment, chemical biology, asymmetric catalysis, natural products and energy. So, we used to see chemistry everywhere. Mostly organic chemistry is present in our day-to-day life, which we come across. When we went to hospital, we use our medicines and the injections that comes under organic chemistry, and in our day-to-day life we use perfume, shampoos and body lotions. In all those chemical compounds are present that comes under organic chemistry, and in our day-to-day life we use transportation. For that we need a fuel that comes under organic chemistry. So, this is all about organic chemistry. Now coming to inorganic chemistry. Inorganic chemistry deals with elements and compounds other than carbon and hydrogen. The compounds which are having carbon and hydrogen which comes under organic chemistry. Apart from carbon and hydrogen, remaining all compounds comes under inorganic chemistry. So inorganic chemistry covers all the compounds except organic. So inorganic chemistry studies are crystals, catalysts, minerals, metals. As we know that most elements on the periodic table are inorganic. And inorganic chemistry has applications in every aspect of the chemical industry, which includes catalysis, material science, pigments, surfactants, coatings and medications, fuels and agriculture. So some of the well known inorganic chemistry things which are around us are diamond, water. Water is an inorganic compound. NaCl, which we use for which is also known as a common salt, table salt, and sand, SiO2, carbon dioxide which we release, and these are the some of the structures of inorganic chemistry. This is the hexagonal structure which comes in inorganic chemistry. So this is all about inorganic chemistry. This is the basic information of inorganic chemistry. Now coming to industrial chemistry. Industrial chemistry is a branch of chemistry which applies chemical and physical processes towards the transformation of raw materials into products that are benefit to humanity. And industrial chemistry is important to manufacture new products. Raw products are dissolved, heated, filtering and various other techniques to form a new products. Examples of industrial chemistry are petrochemicals such as ethylene, propylene, benzene, styrene and so on, and ceramic products. So this is all about industrial chemistry. Now coming to nuclear chemistry. Nuclear chemistry is the subfield of chemistry which is dealing with radioactivity, nuclear process and transformation in the nuclei of atom. While the common perception is that nuclear chemistry involves only the study of radioactive nuclei, but as well as nuclear chemistry is much more interesting than that. Nuclear chemistry is the study of the chemical and physical properties of elements as influenced by the changes in the structure of atomic nucleus. Nucleochemistry or radiochemistry is interdisciplined with a chemist, physicist, geologist and engineer. This is all about nuclear chemistry. So till now we discussed all the basics of the branches of chemistry. So simply one more time I want to repeat. Simply analytical chemistry is of two types, qualitative analysis and quantitative analysis. Qualitative analysis means it is used for the measurement to determine the components of a substance, and quantitative means it helps to identify how much of each compound is present in the substance. So these analyses are used for identifying an unknown sample present in that. So this is all about analytical chemistry. And the next one is biochemistry. Simply it is the study of chemical process in living organisms which is called a biochemistry. So in our body everything is made up of atoms and molecules of different chemical components like a carbon, hydrogen and an oxygen. And the other one is organic chemistry. Simply organic chemistry is a study of carbon compounds such as fuels, plastics, food additives, drugs which we are using in our day to day life. And organic chemistry deals with the study of carbon and the chemicals in the living organisms. And now coming to inorganic chemistry. Inorganic chemistry deals with elements and compounds other than organic compounds such as carbon and hydrogen. And whereas industrial chemistry is very important to manufacture new products, raw products are dissolved and then heated and molded into a new product which are useful to mankind in every aspect. And the last but one, nuclear chemistry. Nuclear chemistry is a study of the chemical and physical properties of elements as influenced by changes in the structure of the atomic nucleus. So this is all about the branches of chemistry. We were in this video we went through all the basic details of all these branches of chemistry. If you like the video, please do like, share and subscribe. Thank you for watching.